Back to our discussion of modern computer vision with PyTorch, and in this session we'll be looking at learning about the different building blocks of the artificial neural network. We know that the neural network consists of a collection of weight or tensors or matrices and some mathematical operations which replicate the way the human brain functions. So there are some component of this architecture. Essentially, you have the input layers, the hidden, also referred to as intermediate layers, and the output layers. In the hidden layers, that is where you have the weight being learned. You have the weight and the bias. So the layers connect the input and the output, and it does transformation on the input data. That is essentially where the patterns of the input is being learned to be able to map to the output. So let's look at how a typical structure of a neural network looks like. So in this that we're seeing, you see here that we have the input from I1 to IN. So those are our inputs. Then you have the output, which is from 01 to 0M. In between the input and the output are our hidden layers. So, and when you have more than one hidden layers, then we refer to this as the deep neural network. So, what in an hidden layer, in a layer consists of multiple neurons. So you can have as many neurons as possible in a layer. So that now talks about the concept of the width and the depth. So when you talk about the depth, you're talking about the number of layers that we have. Like here now you have k hidden layers, so the depth is k. So if you have just one hidden layer, so essentially in literature they will count that as a two layer neural network. They take the hidden and the output and they call that 2. So if you have like 3 hidden layers, they call that as a 4 layer neural network. So they count the 3 and the output as 1. So but essentially you know that the hidden layer is just 3 in that situation. So that's the depth. Now the width is in a particular layer you can have more and more number of neurons, so that it's the width of the neural network. So if you have like 5, so the width is 5, and if you have like 20, so the width is 20. Most essentially the width often varies from one layer to another, as you will see. You see here that the width here is more than the width and the output layer, so it can also varies within the intermediate layers. So the nodes are the one represented in the circle. So now in the output layers, depending on the task at hand, whether we try to predict a continuous variable or a categorical variable. So continuous variable is like you're trying to predict a number, let's say the price of a house. But categorical variable, let's say you are predicting different categories, different classes. Let's say it's discrete classes. Maybe it can belong to a cat or a dog. So those are 2 classes. So that's our categorical. So if the output is continuous variable, that is, you just want to get a number, then you just use only one node in the output layer. So instead of having all of this, you just have only this one. Then you don't need that, since you're just predicting a continuous value. Okay, so let's look at how a single neuron looks like, and I would like us to continue with this in the next lecture so that we can explore this fully. Thank you, and see you in the next one.